Hi, children. Today we will do some problem on Gauss theorem. So that day I have told you that the quotient surface cannot be a fixed geometrical surface like the sphere. We should always prove something which are generalized in nature. So see, this is the uh, plastic cover of uncle shape, and here is Q. And we know that the flux is 4 pi Q. Now, from here, we will see what happened. There is one very good problem. After taking any irregular surface, let us now go to regular ones. So now we have a sphere. So this sphere has got a charge Q at the center. So with Gauss theorem, we will get one very important relation. Flux is 4 pi Q. You know that. We have told you this is a sphere of radius r. Now, electric intensity is flux divided by surface area of the sphere. So this is 4 pi Q is the flux, and the surface area, you know, the surface area of a sphere is 4 pi r square. So E is Q by r square. So what do we get here? This is the proof of the Gauss theorem. Electric intensity is Q into 1 by r square. 4 pi cancel. So now we will come to this one. Here, that day I told you that, see, we will have here the infinite plane sheet. See the charges, it is positive charges. We want to find the intensity after knowing Gauss theorem. So here I have planned this for you so that you'll understand it is 3 dimension. So this is the quotient surface. This is the quotient surface, and this is unit area. Inside it is nothing there. It is a rectangular parallelepiped, hollow one, and this is unit area. So what we do here now is, see, this is the electric charges, and what will be the charge here? The charge here will be the charge per unit area, which is sigma. So sigma charge is inside this quotient surface. So now what will be the total electric flux? The total electric flux we'll have to draw like this. See, sigma is the charge inside this quotient surface, rectangular quotient surface. So what we will get here is that the field will be along this perpendicular to the plane of the sheet charge. This sheet is charged, so perpendicular to this there will be electric field from the paper to me and from the paper inside that. So electric field this side and electric field on the other side. So what about this? What about the electric field perpendicular to this? The electric field perpendicular to the surface of this, to the side of this system, they are all 0. The electric field is 0, so only E to this side and E to the back of the paper. So here we'll have what? We will have, from Gauss theorem, we will have twice Ke. Twice Ke will be 4 pi sigma. So from here, we will get the intensity. the intensity will be, the electric field intensity will be 4 pi sigma by 2k. So it will be 2 pi sigma. So this is the one of the problem we'll get from the intensity of the electric field. And why we call it infinite? Because if it is infinite, all the lines of force will be perpendicular to the plane of the paper. So this is one very good result from Gauss theorem. Remember this. Remember, the field perpendicular to this face, they are all zero. Only e to this side, e to this side, e to this side. So from here we get twice ke is 4 pi sigma. So to prove this, we have used a quotient surface of unit area. So you're clear. This is very clear for the time being. So this is one problem. The intensity is twice ke 4 pi sigma. So E will be 4 pi sigma by 2k. So it is 2 pi sigma by k. So now this is one. Now we will come now to a problem that I gave you some time back on current electricity. See, this is a bulb. This is electric bulb you have at home. So this is 100 watt, this is 60 watt, and this is 40 watts. Then I ask you, which one will be the brightest when the bulbs are connected not in parallel but in series? You don't need to do any arithmetic, or you don't need to do any calculation. Just remember the basic. The highest power bulb will have the lowest resistance. Remember that. Highest power, lowest resistance, medium resistance, and then the lowest power bulb will get the highest resistance. And now what is I? I will be same throughout. I through this, I through this, I through this will be same. So what is brightness? Brightness is I square R. So I is same for 100, for 60 and 40. So now I is same. So I square into R. The brightest will be what? The 40 watt. Why? 40 watt has got the largest R. 60 watt medium, so it will the brightness will be between 40 and 100, 61, and then the dim one, the most dim bulb will be 100 watt. See the principle, I square R, remember that. And what are the principle? The highest bulb will have the lowest resistance, the lowest power bulb will have the highest resistance, and I square R, this will be brighter than the 100, this will be brighter than 60. So we'll end here.